Hello everyone, welcome to the next lecture on the PYQ series. Today we will discuss about inner product. We will cover all those questions from the GATE examination 2004 to 2023. We will see how you can solve each question within the help of the 15-second trick. Myself Dr. Harish Garg, you can simply follow my YouTube channel and you can simply scan and join my WhatsApp group for this. What you can find on my YouTube channel, there is a playlist of the CSR UGC NET where you can find the PY questions related to the topic wise like quadrature formula, uniform convergence, probability and statistics, Bayes theorem, heat transfer and many more are here. Also you can see there is a PY question of the complete differential equations, Eigen's value, integral equations, linear algebra, real analysis all in my YouTube channel. Now let's start with this. Make sure that in each year, in either of the examination, one question will definitely ask from the inner product or inner product space. So what is the unique approach that I will explain you in my YouTube channel. What is that? Firstly, I can go through some definitions and then I will tell you the shortcut tricks for solving the problem. Firstly, what is the inner product? So any function f is called as the inner product if it satisfies the four properties. So as all of you know that first property is called as the positivity, symmetry, additivity and homogeneity. Fine. For example, if you consider as the standard inner product, it is nothing but the dot product of the vectors x and y. If you consider about the matrices, then instead of the x transpose y, it's a matrix we call as the trace of x transpose y. Or how you can express that trace, which is nothing but the double summation of xij and yij. Another concept which we needed here is a norm. So any function f is said to be the norm, or generally norm is denoted by this one. So any vector, any function, norm is a function whose domain is r raised to power n to r if it satisfies the three property: positivity, homogeneity and the triangular inequality. Like instead of the f, you can also replace with the norm sign, that is norm of x plus norm of y. Or moreover, if x is a single vector, that is a 1 cross 1, then this norm is nothing but my absolute value of this x. There are some standard norms which is defined as a 2 norm, that is called as the L2 norm, 1 norm, that is a summation of this, infimum norm and the p norm is here. Another concept that is widely used in the inner product space is the matrix norm. There are the three kinds of the matrix norm. Usually this is the standard 3 norms. Frobenius norm, that is also called as the L2 norm. Fine. So it is nothing but the square root of trace of this, or otherwise you can write here. We can also write this value in terms of the Eigen's value. Sum absolute value norm, that is the sum of the absolute values, and then take this maximum sum absolute norm, that means we have to find the sum of this and then take the absolute value, maximum of the absolute value. There is another norm that is called as the operator norm, that is mostly used when you are working on the Hilbert space or the Supremum sides or the Hahn-Banach theorem are there, then the operator norm is well applicable. That means you have to find the maximum, or sometimes you denote it as a supremum of a norm of Ax. The last concept which is usually asked in the CSR and the UGC NET examination is the Gram-Schmidt process. Whenever you try to understand the Gram-Schmidt process, there is a one term called as the projection. So that is a very, very important concept. So I will explain you by using the Gram-Schmidt process a lot of question in this lecture. So you firstly find the projection of the v on the u. So if this is my u, for example, you have to find the projection of the v on the u by using the inner product here. The denominator is also called as the norm of u. I can also written this as v dot u. Based on this projection, you can define the inner Gram-Schmidt process. Like if you have the vi's, then the Gram-Schmidt process will provide you the orthonormal vector. What is the meaning of the orthonormal vector? X is said to be the orthonormal vector if x over norm x, it should be 1, and if I say and the another vector x dot y is to be a 0. If only this property is satisfied, then we call as the orthogonal vectors. So then x and y are said to be the orthogonal vector if this property hold. X and y are said to be the orthonormal vector if this property holds, that is this property hold, and y over norm of y is 1. Both should be 1, then we can say it is a orthogonal vector. So then how you can apply the Gram-Schmidt process? The first vector v1 is nothing but the u1, and then second vector, that's the u2, is based on the v2 and the projection of v2, and so on. However, it is very difficult. You can recognize this formula, but I will tell you the shortcut tricks how you can find this. So let's start with this one. So first question start from the GATE 2004. You can read the statement very carefully so that you can solve the question within a 15 seconds. Firstly, whenever there is a question of the inner product like of this, try to identify that what kind of the inner product it is given to you. You can see this is a standard inner product. What is the standard inner product is? That is the dot product of xi, yi. That is the standard inner product. Now you can see the function is defined you as r4, that is a vector is my here, which is nothing but x2. Then your target is to find a vector w or v so that this will be well defined. So very simple, you can start with the first option. So what is the w? That w is my x1, x2, x3, x4. This is given to you. And what is the standard product is? This is nothing but vi, wi. Fine. I varies from 1 to n. In this case, n is my 4. Now you can check from the first option. So if I take v is my 0, minus 1, 0, 0. Is the dot product is minus of x2? Yes, because we need a minus of x2. So it means this is the correct option. If I take this vector and w is my this vector, what is the dot product of this? So dot product is minus x1 minus x3 plus x4, which is not equal to minus x2. So this option cancel. If you look about the third option, the dot product will be x2, but we need a minus of x2. This option cancel, this option cancel. The answer will be A is the right answer. So you can see you have to just identify which kind of the inner product given to you. So this is the inner product. Now you can simply start with these elements. Okay, look at this one. What is given to you on this R square? Inner product is defined, and now in this case it is not a standard inner product. Like in this case, this is a standard inner product given to you, but in this case inner product is defined like here. I will tell you the simplest tips for you. Whenever you are working on the R2, fine, you always construct a matrix of 2 cross 2. The first element is x1, y1, second element is x2, y2, whatever given to you. Now you can write this. What is the coefficient of x1, x2? You can see the coefficient of x1, x2 is 1. Coefficient of x1, y2 is minus alpha. It's a minus alpha. Y1, y2 is 1. Now what is the shortcut tips for you? Whenever you have a 2 cross 2 matrix or 3 cross 3 matrix or 4 cross 4 matrix or n cross n matrix, then you have to check whether it is a positive, definite or not. That's a simple rule. If it is a positive definite, then you can say this is my inner product, otherwise not. Or you can find the eigenvalues. If you prove that all the eigenvalues are my strictly greater than 0, then again it is my inner product. But here you can see it is not an easy task for you to find the finding eigenvalue. But again you can see that the sum of the first row is 1 minus alpha, sum of the second row is 1 minus alpha. So definitely one eigenvalue is 1 minus alpha. And we know the sum of the eigenvalue will be 2. So what will be the second eigenvalue? It will be alpha plus 1. So when it will be greater than 0. So when if for all alpha, that is not true, because if I take alpha is say 7, it is a negative. So this option cancel. If alpha is 0, that's true. If alpha is less than 1, then I may take as a minus 0.3 or minus 7, then this number will be negative. If I take mode of alpha is less than 1, then this number will always be positive. So this is the most appropriate one because this is only alpha. So the right answer is my D. Fine. This is the first method. You can start with the eigens value. But I will tell you the another method. One more method you can do, like this is the first method I can write for you here. Then what will be the second method is, You can think about the positive definite. What is the meaning of the positive definite? The first value 1, it should be positive. Second is the diagonal entries, the determinant of this. What is the determinant is 1 minus alpha square should be greater than 0. So what is the meaning of that? Alpha square minus 1 should be less than 0. What is the meaning of that? Alpha is strictly less than of 1 is the condition for that. Otherwise, you can find the eigenvalues. Then you can simply see this property holds. So this is the second method. You can apply either the second method or you can apply the first method, that's on your choice. So you can see the next part. So for x comma y, we have defined the inner product space for the 2 cross 2, which of the following is defined here. What is the inner product given to you? So this is the inner product given to you, that is x transpose a y. The first way is you can check for each property whether it's satisfied or not. It is not an easy task to check all those 4 properties. So you can see it's a 2 cross 2 matrix. So what is a 2 cross 2 property? That is, either you can find the eigenvalues. If all the eigenvalues are strictly greater than 0, then it is an inner product, or otherwise if you find it's a positive definite. Look at that. What are the eigenvalues of this? 2 and 3, which is greater than 0. So this is the right answer. In this case, you can see the sum will be, it's a -1, it's a +1. We can't say that. So you can find the eigenvalue. This is a first method. I again told you this is a first method. How you can find the eigenvalue? The sum of the eigenvalue is a 4. Product of them is a 3 minus 4. It's a -1. So clearly says that. Now you can see the determinant is a -1. So it will happen only when at least one of the values should be negative, because the determinant is a negative. So in this case, all the eigenvalues are not greater than 0. This option is cancelled. What is the determinant of A? It's a 2 minus 4 minus of 2. And we know that 2 eigenvalues, the product of the eigenvalue is a negative if and only if one eigenvalue is a negative. So it means this option is also cancelled out. Look at this option. The determinant will be minus of 2 plus of 2 is a 0. Fine. But we need a strictly greater than 0. So this option is also cancelled. Right option is my A is the right answer. This is the CSR of I think 2020 examination or 2019 are there. What is the second method? What is the second method? Instead of finding the eigenvalue, we can start with a positive definite. So we can see here, this is the second method. For this matrix, look at the first value, that is the 2, which is greater than 0. Look at the determinant of this 6, which is a greater than 0. Therefore, this implies this is my positive definite. So this is the right answer. Look at the second option. The first value is a negative. It means this is not positive definite. Look at the third option, 2, that's the first value. 2 is a greater than 0. Then it's a 2 cross 2, it's a 2 minus 4, which is not greater than 0. Again, it is not positive definite. Look at the last value, it's a 2, it's a greater than 0. And 2 plus 2, which is not greater than 0. Again, it is not positive definite. So again, your right answer is, your first is the right answer of this. So what is the tips for you here? You can see, if you have the matrix like A, B, C and D, then this is said to be the positive definite when if the first value A should be greater than 0, second value is the determinant of this, that is AD minus B square should be greater than 0. Then you can say this is my positive definite. If you have a matrix of 3 cross 3, B's, A, B, C, D, E, F, G, H, I, then this is said to be the positive definite if the first value is a greater than 0. Then the next principal minor, that's a 2 cross 2 matrix, determinant of the 2 cross 2 is AE minus BD should be greater than 0. And the third is the complete determinant should be greater than 0. If these properties satisfied, then we can say the positive definite. So you can apply either of the methods whenever there is a 2 cross 2 matrix. Now which of the following is inner product? Again you can see it's a 2 cross 2. It's on the R scale. So if I define the first matrix, the first value is my x1, x2, second is my y1, y2. What is the coefficient of x1, y1? 1. x1 y2 is my 2, x2 y1 is my 2, this is 1. So you can see first value 1 is a greater than 0, second value is 1 minus 4, which is not greater than 0, so it is not inner product. Otherwise you can find the eigenvalues, like eigenvalue is my 2 of lambda minus of 3. So clearly says that because the determinant is a negative, so one eigenvalue must be negative. So again this option is cancelled out. Now look at the second option, x1 x2. What is the coefficient of x1 y1? 1. x1 y2, it's my again 1, this is 1 and 2. The first value is 1, which is greater than 0. Second is the 2 minus 1, which is positive, so it means this is the right answer. Look at the third option, it's a 1 1 1 1. First value is a greater than 0, that's fine, but the second determinant is a 0, which is not greater than 0. This option is cancelled out. Look at the last value, it's a 1, it's a x1 y2, it's a minus half, it's a minus half, it's a plus 1. First value is a greater than 0. What is the determinant is 1 minus 1 over 4, which is 3 by 4, which is greater than 0. So this option is also correct option. B and D are my correct option. And you can see there is a word of R. So more than one correct options are there. This question is asked in the February 2022. You can see within a couple of seconds you can get your answers in a correct way. I hope you can put a like on this video if you are interested in this one. Now look at that. Let S be here. This is the standard inner product. Fine. Then you have to find the dimension of this M. Okay, so whenever there is a question of the inner product and some set is given to you, so you can see S is the subset of R cube. Your first target, what is the tips for you? Your first one is to find the rank of this matrix S. Fine. Always remember you can find the rank of this matrix S, or you can find the number of the linearly independent vectors from this S. That's always the first step for you. Now you can clearly see that what is the how you can find that if I simply say 0 1 1 1 0 1 minus 1 2 1. Fine. So clearly says that if I add the last two elements, what will happen? 0 1 1 0 1 0 1 2 2, and you can see these two rows are same. So what is the rank of the S? Rank of the S will be my 2. Or you can see if I call this is my V1, V2 and V3, you can see V1 is nothing but V2 plus V3 divided by 2. Fine. So it means the rank of the S is my 1. Now what is the dimension of the M? M is my here. So you can see cardinality is N by using the rank nullity theorem, or dimension of M minus rank of elements of this S, because the Y is the element of the S. What is the rank of the S is 2. So 3 minus 2 is my 1. Because whenever there is a equality 0, it means you are talking about the nullity. You have to find the dimension of the nullity. So rank nullity theorem is dimension is 3 minus elements of this Y. From where this Y came, Y is the part of the S. What is the rank of the S is 3 minus 2. 1 is the right answer of this problem. Now look at this another one, which is given to you as a real positive symmetric matrix. Inner product is defined like here. N is the any cross matrix, which is defined like this. S is the adjoint of T. What is the meaning of the adjoint of T? That means I can denote like here. Fine. Then you can see if I apply the operator X on the both side, it will be my T star of X. And S of X is my Cx. So what is the meaning of that? They are equal to this. Then your target is to identify what is my C. A very simple target. There is no need to think about that. We can apply this property. X comma Y is the elements of Y is the inner product. So I can apply this element, say T of X. Fine. So I can use this property. What is the T of X? T of X is nothing but the Cx. Fine. Or sorry, it's not a T star is a Cx. So this is my X comma Ax. So now I can apply this value. So Y transpose, that is a A transpose, sorry, it's a AX transpose, AX transpose B of X. So I can open this is the X transpose, A transpose B of X. Fine. Second, I can apply this property, T star of X comma X. What is my T star? What is that? T star is my CX comma X. Again, I can apply this property, X transpose B of X. Now if you compare two of them, because we all know they both are equal. Why? Because we know X comma T of X is same as that of T star of X comma X if they are the adjoint. So from here you can see BC is nothing but A transpose B. So what is the right answer? C is nothing but my B inverse of AC is the right answer. This is a question from the GATE 2021. It's the inner product. What is the inner product? It is not given to you. P and Q are here. Very simple question again. If you look about here, if I take the LCM, what is that? So U comma V is less than equal to, this is nothing but the norm of U, fine, plus norm of V. So since it's a square root is not there, so I can written here. So can I written this number as norm of U minus norm of V whole square? I can take on this side. So what is that? It is always correct because this is always true. Because square is always the positive quantity. So P is a correct statement. Fine. Now look about the Q. How you can check about the Q? We can start from here. U comma V is nothing but 2U comma minus of V. So I can take 2 as a common, that is the same thing, minus of V. Now I can take minus common, it's a real, so there is no problem about that. It's a U comma V. So what is that? On the left hand side is also U comma V, right hand side is minus of 2. So what is the meaning of that? 3 times U comma V is my 0. So what is the meaning of that? U comma V will be 0. So when it will be 0, that's only meaning of that this will be, here is the, so this is, you can see V is a 0. Again this is my correct statement. So both P and Q are my correct statements. These are the standard result of this. Okay, look at this another one. Let N be the, this is a CSN net question. Now you can see this is N cross N matrix. So for the very simple case, I can simply take N is my 2 cross 2. Fine. A and B, which are the following are the inner product on the real symmetric matrix. So it means A and B are my 2 cross 2 symmetric matrix. Then the inner product, which of the following is inner product? Very fine. We all know inner product is always be greater than 0, and whenever they are same, it is a 0 if and only if the matrix is 0. Fine. This is property we know. So very simple. You can firstly think of the trace. So I need a positive. If I think about this value is my positive, this value is a negative, then the product of them is a negative, which is not satisfied. So can you think about any of the matrix whose trace will be the positive? So say 2, 3. So you can see that trace of A is my 5, which is a positive. Can you think about any of the matrix B whose trace is a negative? You can say about minus of 2, minus 4, 0, 0. So you can see trace of B is my minus 6. So the product is a negative. Both are my symmetric matrix. This property is satisfied, but this property is not satisfied. It means this option is cancelled. Similarly, you can see the trace of A. In this case, trace is my 5. Trace of B is my minus 6. So it is again not greater than 0. So this option is also cancelled out. Now you can see the determinant. Now you need a AB. So what is that? How you can find the determinant of this? So if I say what is the determinant of this? 6. Determinant of B is 8. Eigenvalues of this are my 2, 3. Eigenvalues are my minus 2, 4. So how you can find the eigenvalues of the AB? You can multiply them. Or otherwise there's a very simple. If I simply take A and B both are same, which is 1, 0, 0, 0, for example, a symmetric matrix. That's identity matrix. Fine. So what is the meaning of that? Then what is my AB? AB is again I. So determinant of AB is my 1, which is a greater than 0. Fine. We have to discard. Trace is 2, which is again greater than 0. Okay. If I consider this value as a 0, so it means I can consider this number as here. Fine. This is a symmetric matrix. Fine. Then what is my A into B? A into B is again this value. Fine. So then what is my determinant of AB? This is 0. So it means inner product of A comma B is my 0. That means if and only if A is equal to 0. But you can see A is my non-zero. But A is my non-zero. So the determinant is option is also cancelled. Only left option is B, which is my correct option. Very simple. You just think about the any of the 2 cross 2 matrix which satisfied or which does not satisfy the given requirement. Okay, look at this another one. It's a statistics question, but still it's an inner product here. M is a 3 cross 3 real symmetric matrix with the eigen's value this, corresponding eigenvector here. What is the meaning of that? What is a AX is equal to lambda x? This x is my eigenvector. Fine. This lambda is my eigenvalue. Now look at that. What is given to you? Eigenvector is my u corresponding to the -1. So this is given to you. V is my plus of V, and this is my 2 of W. This is given to you. Fine. Consider the 2 vectors x and y as here. Then you have to find the length of this. How you can find the length of this? So your target is to firstly find the value of x, find the value of y. M has the eigenvalues -1, 1 and 2. So what is the determinant of this? -2, which is non-zero. So I can find the value of the x from this case. Because the determinant is a non-zero, so I can multiply this by M inverse. That's an invertible matrix. So I can multiply both sides by M inverse of u plus 2v plus of 2w. So if I open this is M inverse of u. What is the M inverse of u from this case? It's minus of u. Plus, what is the M inverse of v? If I multiply both sides, it's a v. M inverse of w will be my plus, sorry, it's a twice. What is the M inverse of 2w? It's nothing but my w. Fine. This is the value of my x. Now you can find the value of y from here. So I can firstly multiply by M inverse on the both side. So it's M inverse u, it's M inverse v minus 2 M inverse w. What is the M inverse u from here? It's a minus of u. M inverse v is my minus of v. M inverse of w is my M inverse of 2w will be my minus w. Then again we can find the value of the M inverse of minus u, M inverse of v, M inverse of w. So sorry, it's a negative. This is my negative. Fine. So what is the value of the M inverse of minus u? It's a plus of u. M inverse of it's my minus of v. M inverse of v is my half of w. Now this is the value of the y. So from the 1, from the 2, we need x plus y. So you can find the value of x plus y. What is the x plus y? V cancel. Minus of 2v minus of 3 over w this. You have to yes, it's this is minus of 2w. It's a minus v. Is there any correction? It's x, it's a y, so it's a u will be cancelled out. It's a plus v, sorry, it's a plus of v. This is plus v, and this is plus of half w. Fine. Now your target is to find the length of this. How you can find the length of this? What is the u? This is a unit vector. So what is that? You can simply say 1 plus half of scale. So this is 1 plus 1 over 4. It is 1 plus 2, 5 is the right answer. Again, a very simple. Just try to understand the concept of eigenvalues, eigenvector. This is one more question from the GATE 2022. What is given to you is U is the usual inner product, that is my standard inner product is given to you, xi, yi. U is the any vector which is orthogonal, to this one. So can I write this, the vector of this as one element is x, second is my u, fine, where x is my x1, x2, x3, x4, fine. Can you find the value of u so that you can use the dot product and it comes to be here, which is nothing but my this one, fine. Now a very tips for you always, whenever you want to find the orthogonal matrix, remember, fine, whenever there is a orthogonal vectors are given to you, this is the orthogonal vector, always try to find the projection, fine. What is the projection of the u on this? So the projection will be my u dot v over u dot u. That is a simple projection rule are here. Okay, I will tell you two methods. The first method is by using the projection. So since this and this are orthogonal, so we can apply the projection. What is the alpha? Because alpha is a scalar product, so it is nothing but u dot v divided by norm of here. So you can see what is the u dot v. V is my given to be here. It's a standard inner product, so I can dot product of them. It will be 1 minus 2 plus 1 plus 1 divided by norm of u. So you can simply say it is it is u dot u. So you can simply take as a 4, fine. So once you can see it is my 4, what will be your, its norm is my root of 4. It's a norm of this. So what is that? It is my 1 over 2. So alpha is my 1 over 2. Alpha square we need, it's 1 over 4. That is 0.25 is the right answer. Make sure what is the u dot u? It is nothing but elements wise of this ui square. Fine. This is the first method. When you are thinking about the orthogonal, that's always with the projection. There is one more way. I can write for you here. So what is the given statement is the vector u and v, this is the orthogonal, so dot product is a 0. So how you can open that? You can see u, what is the v minus alpha u? V is my here, u is my this, so this element will be v minus alpha u. So 1 minus alpha, minus 2 minus alpha, 1 minus alpha, 1 minus alpha, fine. Now you can see this is my u, v, this is my v. So what is a v minus u alpha? So I can multiply this by alpha and subtract from here. Now what is the u? Is 1, 1, 1, 1. So what is the dot product of this? This, by using the standard inner product, you can find again alpha from here, which comes to be again as a 1 by 2. Okay, which of the following is there? Which of the following define an inner product? Again, these are the two vectors. So I can define this 2 cross 2 matrix. Elements are x1, x2, y1, y2. What is the coefficient of the x1? Is a square. x1, y2, it's a ab. This is again a ab. This is the b square. So you are unable to find the eigenvalue as quickly. So I can apply the positive definite. We will check for the positive definite. First value is a square, which is always be greater than 0. Irrespective of the value is positive or negative. Second value is a square b square minus ab whole square, which is a 0. It is not greater than 0. So this is true for all the a and b, which can never be greater than 0. So for what value of the a and b? There is no value of the a and b for which this defines the inner product. So this option cancel, because the second condition is equality 0. Fine. So it means it is true for all AB, but which is not always greater than 0. Hence there is no value of the A and B which satisfied the inner product property. Okay, look at this. This is the standard inner product again given to you. This is the standard inner product. M is my given to be here. Then what is the dimension of the M complement? So always remember dimension of the M complement and the dimension of the M is my vector space, is the dimension of this 4. How you can find the dimension of the M? Dimension of the M from here. So what is the dimension of the M by using, because I can return this value as x1 minus x3 is 0. So since it is a 0, you have to find the dimension of the basically nullity. So what is that? It's elements of the 4 minus number of the linear independent is, there is only one equation, that's why it's a 3. So dimension of M is my 3. So what is the answer of this value? This is nothing but 1 is my correct answer. Fine. Why I consider as a 1? Because there is only number of the linearly independent conditions. So what is, how many linear independent conditions? There is only one condition given to you as x1 minus x3 is 0. So that's why there is a 1 subtraction. So that's the dimension of this M. Okay, now again there is an orthonormal. So whenever there is an orthonormal, we will try to find the projection. Fine. So consider the orthonormal set. You can also check whether it's orthonormal or not. What is the property? V1 dot V2 must be 0. Fine. V1 dot V3 must be 0. V2 dot V3 must be 0. And the norm of V1 should be 1. Norm of V2 should be 1. And norm of V3 must be 1. You can see that 1 by root 16, 2 by root 16, 1 by root 6 cancel out. Standard inner product is given to you. U is given to you as A, B, C, such that the inner product of the U with respect to V1 is my 1, U with respect to V2 is my 2, U with respect to V3 is my 3. Then you have to find the value of here. A very simple shortcut tricks I will tell you. Fine. What is the shortcut? Firstly, how you can think about that if you never know the shortcut tricks. You can take U as A dot B. You can multiply this. You will get A by root 3 minus B over root 3 plus C over root 3 is 0. Then for the second one, it's A over root 6 plus 2B over root 6 plus C over root 6, and similarly for third. And then you can solve this 3 by 3 matrix, find the value of A, B and C. But there is no need of them. Whenever there is an orthonormal, you can find the projection. So A is the first vector. Fine, that is the x vector. So it's a U dot this divided by norm of V1. Fine. B is U dot V2 divided by inner product of V2 comma V2, or you can say the norm of V2. And C value will be U comma V3 divided by V3 comma V3. So now you can see what is the U dot V1? 1. No, because this is the orthonormal, so norm is also 1. So root is a 1. This is 2 over 1. So now you can easily see that A, B, C are 1, 2, 3. So what is the right answer of this? 1, 4 plus 9, 14 is my right answer. So you can see within a 15 seconds you can solve this whenever there is a question of the orthonormal. I hope you can put a like on my video. Okay, now look at this one. This is another category. Whenever there is a question related to the square of the distance. Fine. Again, one more question is there. You can find the distance of the point from this. Again, I will tell you the shortcut tips for you. Firstly, I will explain this. What is the meaning of that? There is a one point of 1, 1, 1. You have to find this, say subspace. Say this is the subspace of here. You have to find the distance of this one. There are so many methods are there. Firstly, I will tell you the shortcut tricks, and then I will explain you the various other methods. What is the shortcut tips for you? Firstly, whenever it's a 3 cross 3 matrix, like this is the 3 cross 3, you can find the equation of this plane. This is my equation of the plane. How you can find? That's a very simple. You can find this I, J, K. Fine. The first value is my 1, 1, 0. Second value is my 0, 1, 1. Fine. Now can you find this answer? It's a 1 minus 0. It's a minus of J, 1 minus 0, plus of K, 1 minus 0. So what is that? I minus J plus K. Now it is given as a usual. That's my standard inner product. So if any point on this called as the x, y, z. So what is the equation of the plane? This is x minus y plus z is equal to 0. Fine. This is the equation of the plane. Now how you can find the perpendicular distance of this? That's again simple. You can substitute this value as a 1 minus 1 plus 1 divided by 1 plus 1 plus 1. If you remember, if you have a plane of ax plus by plus cz is equal to 0 and the point is say x naught, y naught, z naught, how you can find the distance of them? Divided by a square, b square, c square, and in the numerator you have to substitute this value of here, this is ax naught plus by naught, if I call as a d also, plus cz naught minus of d. That's the meaning of this. Now you can see this value is my 1 here. So what is the answer is 1 by root 3. So now your target is to find the 3d square. Right answer is my 1 is the correct answer. This is the first method. You can find it in a very simple manner whenever there is a 3 cross 3 matrix. Another method is, what is another way? This is a second method. You can opt any of the one. You can opt any one of them. So firstly you can find the span of this. What are, if I consider this is my w, what are the elements of this? I can multiply this by alpha, this by beta. So the elements of this is alpha, alpha plus beta and beta. Fine. Then your target is to find the distance from here. So what is that? Distance will be alpha minus 1 square, alpha plus beta minus 1 square and beta minus 1 square, or I can simply square, so it is 1 of this. Then your target is to find the unknown values of the alpha and beta. So if I consider this is my f, how you can find the unknown value? You can take the partial derivative with respect to a alpha and beta to be a 0. So what is that? If you take the partial derivative with respect to alpha, it comes to be here, this minus 1 0, and if you come with the beta, it will be my here. Fine. So once you solve, you will get the value of alpha, you will get the value of beta. Substitute the value of alpha and beta here, and then you can find the distance from the point 1, 1, 1. But that will take a lot of the calculation. You are unable to solve this question within a 15 seconds if you are using this method. But I always recommended you can apply this trick. There is one more method. There is one more method. That is a third method. You can solve this question in a very simple way. How you can solve? I will tell you with the help of this example. You can see it is a 4 cross 4. Fine. Then you are unable to write I, J, K and say of say P cap. Then you have a 0, 0, 1, 1, 1 minus 1, 0, 0, but you are unable to find that determinant. Fine. Then what you can do is, again, the first method is you can write the span of this, multiply this by alpha, multiply this by beta, you will get this number as beta times, then second number will be my minus of beta, third is alpha and alpha. This is my vector w, that's a span. You can find the distance of from the 1, 1, so it will be my 1 minus beta over root 3 plus second plus third and fourth, and then partial derivative with respect to alpha, partial derivative of this with respect to beta to be a 0. That will take again a very lengthy time. I will tell you again the shortest way. How you can solve this problem? We can solve this problem by using the Gram-Schmidt process. Very simple procedure. How you can do? Firstly, check whether they are orthonormal or orthogonal. If they are orthogonal, then you can apply that. You can check. I can firstly clear the screen. If I call this is my v1, can v1 dot v2 is a 0? It's a 0, 0, 0, 0. Yes, this is 0. What is the meaning of that? This is my orthogonal vector. Fine. Check whether norm of v is my 1 or not. Like, what is that? If I say 0 plus 0 plus 1 divided by 2, it's a 1. Is it also the 1? 1 plus 1, 2, 2 divided by 2 is there. That's fine. So they are orthonormal as well. So whenever there is orthonormal, you can apply the Gram-Schmidt process. Or very simple. You have to find the projection. Fine. How many vectors are there? There are the 2 vectors. You can find the 2 projection. The first one is, if I consider this vector is my v1 and this is, and I call this is my say u, then you can find the projection as u comma v1 divided by v1 dot v1. Second is u dot v2 divided by v2 comma v2. Fine. So what is that? Or because you have to find the distance, so you have to multiply this vector by v1, this vector by v2. So what is the u dot v1? If you dot product them, what will happen? 0, 0, 2 by root 2. Fine. Because this is the orthonormal, the value will be 1 always. So what is the v1 is? 1 by root 2 of 0, 0, 1, 1. So what is that? 1 by root 2 is cancel out. 0, 0, 1, 1. Similarly for here, what is the u dot v2? It's a 1 minus 1, 0, 0. It's a 0. 0 over 1, v2 is a 0. So the total projection is, so you can add the element. This is my 0, 0, 0. So the elements are my 0, 0, 1, 1. Fine. Now you can find the distance of this 1, 1, 1, 1, and the vector is 0, 0, 1, 1. So what is the distance? It's my 1 minus 0 is 1 square, 1 minus 0 is 1 square, 0 square plus 0 square is a root 2, and you need to find the square of that distance. The square of that distance will be my 2 is the right answer. So this is the way you can solve this problem as well. So that's on your choice. You can solve the same question again with the help of the previous method. So let me explain this question again for you. As I found the answer is 1. So I can apply the Gram-Schmidt process. Firstly, you can check whether their dot product is 0. Okay, so you can see if I called this is my v1, this is my v2, clearly says that v1 dot v2 is non-zero. It means they are not orthogonal. Fine. So you can firstly make them as a orthogonal. How you make them as a orthogonal? That's a Gram-Schmidt process. The first vector should be 1, 1, 0. Fine. The second vector you can start with here 0, 1. You can find the projection firstly. I can use the same rule. So how you can find the projection? That is a v2. If I call this is my u1. So u1 comma v2 divided by v2 comma v2. Fine. So into of v2, whatever you have written here, you can find this value. Similarly you can find the other value, and then you can find this as here. You can simply do that. That's a very simple. Otherwise this is a 3 cross 3. We will see in later on. Now the major important category is the Gram-Schmidt process. Fine. That's the way how you can construct the Gram-Schmidt process, like here. Okay, so I will tell you here. This is the orthonormal basis. You have to construct this one. Remember, whenever there is a question of the Gram-Schmidt process, you have always look about the vectors. That is the option. Check whether this v1 comma v3 and so on, the dot product must be 0. Those who are not 0, then we can discard the option. Look at that. This value is 1, 0, 0. The dot product is a 1. So this option is cancelled out. This value is like 2 by root 3. 2 plus 2, 4. 4 minus 4. It may be the right answer. 1, 1 minus 2. It may be the right answer. 2 minus 1 minus 1. It may be the right. So B option is strictly cancelled out. Then whether the dot product is a 0. So 1 plus 1, no. So it means they are not the orthogonal. Fine. So you have to make them. So your target is to find the vector of u1 and u2. That is here. So what is the u1? u1 is the first vector. That is 1, 1, 1 divided 1, 1, 1. Fine. 1, 1, 1. So look at which of the option is not 1, 1. All are there. Then how you can find this one? You can find the projection. So look at the second vector firstly. You can write the second vector minus 1 minus. Find the dot product of this. What is the dot product is? 1 plus 1, 2 minus 1 is a 1 divided by, you can find the norm of the previous vector. What is the norm of 1 plus 1 plus 1? 3 into, you can find this previous vector. I can again repeat you can start with a v, that is a vector, find the dot product divided by the norm of this, that's the dot product of u1 u2 into this. So can you find the answer of this? It's a 1 over 3, 1 minus 1 over 3, 2 over 3, 1 minus 1 over 3, again 2 over 3, minus 1, minus 1 over 3, minus 4 over 3. Now check about the option which contain the 2, 2 minus 4, or you can say 1, 1 minus 2. Fine. So you can see 2, 2, 4, that's fine. 1, 1 minus 2, fine. This option is cancelled. It's a 2 minus 1, 1 here. Now out of this, which one is the correct option? You can see you will get as 2, 2 and minus 4. Fine. Now 2 plus 2 and minus 4. Take the norm of this. 4 plus 4 plus 16. So what is the answer is? It's a 24. Fine. 2, 2 and here. No, it is something is wrong because 24 is not be there. So how you can see it's a, check your calculation again. It's a 2 by 3. No, sorry, there is no need of this, because there is no need of this. This is already we have divided them. So what is the orthogonal process? What is the u1? 1, 1, 1 divided by their magnitude, because this is already a magnitude 1. So 2 over 3, 2 over 3 minus 4 over 3 is the right, because here is a root 6 but we have a 3. So only the first option is correct, third option is cancelled. Look at the again. So since the S is the subset of this, so again your target is to firstly find the rank of the S. Fine, because you can see there are 2 elements, there are 3 elements, there are 2 and 2. Clearly says, you can see about how you can see that what is the rank. Can you make them, if I subtract them, you can see if I subtract these 2 elements, what will happen? It's a minus 1, it's a 2, it's my minus 1, which is same of this apart from the negative sign. So what is the rank? What is the meaning of that? This vector, it can be written as v2 minus v1. If I call this is v2, so what is the meaning of that? The rank of this S is my 2. So in the Gram-Schmidt process there are only 2 elements, u1 and u2. So this option will be cancelled. Now look at the, firstly check about whether the dot product is a 0 or not. 1 minus 2 plus 1 0, 1 minus 1 0, 1 0, 1 minus, all are satisfied. So what is the u1? First vector. So what is the element of this? Is a 1 1 1. Second is 2 minus 1 2. Fine. The first value is my 1 1 1. Then second value is, you can write the second vector 2 minus 1 2 minus dot product of this. So 2 minus 1 plus 2 is my 3 divided by square of this 1 plus 1 plus 1 3 into the previous vector. So what is the answer? It's a 1, 2 minus 1 1 minus 2 1. So look at the option which consists of 1 minus 2 and 1. So what is that? 1 minus 2 1. Fine. And you can see the length is not 1. So what is the final answer of this? What is the Gram-Schmidt is? The first value is 1 1 1 divided by their magnitude. Then 1 minus 2 1 divided by their magnitude. 4 plus 1 plus 1 is a root 6. Again you can see it's a 1 minus 1, but we need a 1 minus 2. So this option cancel. It's a 0, but we need a plus 1. It's a cancel. Only right option is my A is the correct option. Now again, these are the orthonormal basis. We can apply the Gram-Schmidt process or the projection. If you look about that, find the rank of this matrix M. You can see that the 2 rows are same. Rank is my 2. So what are the matrix of this? So 1 1 2 and the other value is 0 1 1. Fine. Then how you can apply this? So it means this option is cancelled because the rank is my 2. This option is cancelled. Is that dot product 0? Yes. Is that dot product 0? Yes. So the first value will be 1 1 2. But here 1 1 2 is not given to you. Fine. So the first value is 1 0 0 and so on. So how you can do that? So you can consider the matrix M is given to you and here. Okay. So now you can see this is the X transpose. This is the X transpose. So you have to written like a column. This is the first vector and this is the second vector. Again you can see C1 plus C2 is nothing but my C3. Fine. Now first vector will be my 1 0 0. So 1 0 0. Fine. U2. Write the second vector 1 1 1. Find the dot product 1 divided by the square of this. It's a 1 square plus 0 square plus 0 square into the previous vector. Basically this is my projection. So what is the answer of this? 0 1 1. Fine. So what is the Gram-Schmidt? Now 0 1 1. So 0 0 1. Here we need a 0 1 1. So here is 0 1 1. So what is the right answer of this? First value is my this. You can divide by square of 1 plus 0. Second value is my 0 1 1 divided by square of 0 1 1 is the right answer of this problem. So Gram-Schmidt, whenever there is a question of the orthonormal, apply always Gram-Schmidt process. Again the Gram-Schmidt is here. There is no set given to you. So we can start with this U1. Now it's a 3 vector. U1, U2, U3. First we check the dot product 0 0 0 0 0 0. Fine. This may be the right answer. 0 0 fine. 0 0 fine. 0 0 fine and here. So all may be the right answer. First value is 1 1 0. So this value is not 1 1 0. Fine. Now U2. Find the second value 1 0 0. Find the dot product 1 divided by the square of this 1 plus 1 2 into this value 1 1 0. So what is the right answer of this? 1 minus half. 1 0 is a minus half. Third value is 0 minus 0 is 0. So look at the second value is 1 minus 1. 1 minus 1. The second value is not 1 minus 1. This option also cancel. 1 minus 1, 1 minus 1. Fine. Now third value, you can find the third vector. Third vector is my 1 1 1. Fine. Now you have the two vectors. One is this, second is this. Now you have to apply the 2 times projection. First this with the help of this. What is the dot product of this and this? 2 divided by 1 square plus 1 square 2 into 1 1 0. Do the same thing for this vector with the help of this. What is the dot product is? 0, 1 half minus half 0 divided by the magnitude of this 1 by 4 plus 1 by 4 into of this vector. Fine. So what is that? So it's a complete 0, it's a 1, so it's a 0 0 1. So the third vector will be 0 0 1. It is 1 1 1. So this option cancel. Right option is my D is the correct answer. Now again this is orthonormal basis. So you have to firstly write the matrix T. This is my X. What is that? This is the X. This is the Y. This is a 0. Y plus Z. Y plus Z. Z minus X. Minus 1. Y and here. Fine. What is the rank of this matrix? You can see if I can simply say 1 1 0. If I add R3 plus R1, so it will be 0, it's a 1, it's a 1. So you can see the rank will be my 2. Fine. So once the rank will be 2, you can see you have to write. Now there is no transpose given to you. So what are the elements of this? That is a row wise. First element, second element. Fine. So rank is 2, all are 2 elements. Now again a very simple. First value will be 1 1 0. 1 1 0. It's a 1 minus 1. 1 1 0 1 1 0. How you can find the second vector? Write the second vector. Find the dot product of this divided by the square of this into 1 1 0. So what is the answer? 0. First value will be minus half. So here is a 1 by root 3. We need a minus half. Fine. 1 minus half is half and this is. So it's here is a 1. I need a minus 1. So first value is a positive. So I can make this value also as half minus 1. 1 minus 1 minus 1 1. Now denominator is same, so I can make the denominator same. I can take 1 by 2 as a common. 1 minus 1 minus 2, 1 minus 1 minus 2. So this option also cancelled. C is my right answer of this problem. Okay, look at this another one. Again the inner product space which is defined here, projection. Fine. What is the rule of the projection? This is the same rule as I told you. Find the projection of the V on the U. So whatever on the vector, it is written on this previous side. So you have to find the projection of x square on the M. What is the M is span. So that is my 1 over 1 comma 1 into projection of x square. Fine. This is the, so you have to find the projection. That means you have to find this value. So what is the x square of 1? You can start from here. X square into 1. So what is that? It is 1 over 3 divided by, what is the integration of 1 of 1? It is my 1. So the right answer is 1 over 3. Always apply the projection. That is a very, very simple concept. Fine. Okay, look at this one. Again the inner product space given to you. V is the span of this element. Okay. Again you can see this is similar of this. M is the span of 1. So what is the meaning of that? What kind of the elements are there? Alpha times of the 1. Fine. So same for here. V is my span of the t square. So what kind of the element are there? Alpha times t square. Then H is the any element of the V. So what is the meaning of that? H is the element of the alpha t square. What is my alpha? Alpha is the projection. Fine. So what is the projection? That is a projection of 2t minus 1 on the t square. Fine, because it's a 2t minus 1. So how you can find that? It's a very simple, 2t minus 1 of t square divided by t square. Fine, into, I can use the same rule. Whatever here, the same in the denominator, u into v. So you can see is a t projection on this. So what is the numerator part? You have to apply this rule, product of this. So it is a 2t cube minus of square. What is the denominator is? This into this is a t raised to power 4. So what is the answer of this? It will be my 2 by 4. It is 1 over 3 divided by 1 over 5. So it's a 1 over 2. 1 over 2 minus 1 over 3. So 1 over 6, 1 over 5. So right answer is 5 over 6 is the right answer. So alpha is my 5 over 6. So alpha into t square is 5 by 6 t square. Always remember, apply the projection rule. You will get your answer within a fraction of second always. Kindly put a like on my video if you feel it's a very good. Okay, V is the real inner product space of the dimension 10. Dot product is a 0 dimension of this x bar. Very simple again. You have to find the dimension of this. Fine. Think about any of them. It means x consists of the 10 elements. Fine. Y consists of the 10 elements. Fine. You have to think any of the vectors whose dot product is a 0. So if I consider this is the simplest one is here, the other one is say this one. Fine. Clearly says the dot product will be 0. Fine. Now from here can you find the orthogonal complement? What is the complement? Where the element is there? In this case it's x1, x2 and up to the x9. Similarly from this you can say this value is my say y1, this is y2 up to y9 and 0. What is the intersection? How many elements are there in the intersection? This first element is cancelled. This element, there is an element, second last element is there. This value intersection is 5. So how many elements are there? There is 8 elements. So the dimension of this problem is my 8. Always dimension is the maximum number of the Li vectors. You may think about like this way. If I consider x1, x2, rest all values are 0. y is my 0, 0, and the last two values are y1 and y2. Again the dot product is 0. If you consider this here, then this value is nothing. This value has some value, some value, some value, and here what is the y complement? This has some value, this has some value, last two values are not there. What is the intersection is 8. Sorry, 2 and 2, 4 are cancelled, is a 6, but this is not the maximum number of the Li vectors. You always remember dimension is the maximum number. So maximum number is only when you can consider this way. Now look at this another one. This is a CSR net examination. We again W is the span of this. Fine. So it means W is the span of this element, like of this. Fine. Then which orthogonal complement defined is their degree at most 2. So what are the bases of this? 1t of t square. These are my bases. Then which of the following is the element of the condition of this? H belongs to the complement. Check about the first option. H is an even function. What is the even function? Out of this is a t square. Fine. So if I substitute this value here, what is the meaning of that? T square. F and G are the elements of the V. I can consider any of the element. Say 1 minus t square. So what is the integration of this? 1 over 3, 1 over 5, which is non-zero. Fine. So what is the meaning of that? Because for the orthogonal, dot product must be 0. So H is an even function. Cancel. If I consider H is an odd function, what kind of the odd function is there? Basis is my t only. So again, you can integrate this over 1 minus. So what is that? This is 1 over 2, 1 over 3 is 1 over 4. Again, it is a non-zero. It means non-zero means it is not orthonormal. Fine. But we need a orthogonal. So this option is also cancelled. So it means this is cancelled, this is cancelled. H of 0 is a 0. You can see it is not true. So it means the only correct option is my C is the right answer of this problem. Okay, look at this another one. Again, you can see inner product space is given to you. Degree is there with the inner product. Is the orthogonal vector is given about here. What is the meaning of the orthogonal vector? F0, F1 will be 0. F0, F2 will be 0. And F1, F2 will be 0. Then your target is to find the C1, C2 and C3. Very simple. We can start with the first one. F0 and F1 by using this definition. F0 into F1, that's a t plus C1. So what is the integration of this? So it will be my 1 over 2 plus C1. So C1 is my minus half. Fine. Now look at the F0 and F2. So that's the integration of F0 and F2. So what is that? It's 1 over 3. What is the integration of the F1? F0. Okay. F0 and F2. I can tell you a simple way. There is no need to solve like F0, 1 into t square is basically a t square. Fine. F0 into F1. If you multiply F0 and F1, there is already a 0. Fine. F0 into is a C. Fine. So basically your target is to find this one. So it is a 1 over 3 plus C3 is 0 by using this integration. So what is that? It's C3 is my minus 1 over 3. So basically this part is there. Fine. Then now you can find this third part, F1, F2. So I can start with the F1 and F2 will be my t square plus C3, C2, F1, C3. Can I write C3 into F0? Yes, you can do. So what is that? It is given to you 0. So how I can open that? This is F1 of t square plus F1 into F1, because okay, this is C2 is outside, F1 of F1 plus F1 of F0. F1 and F0 are 0. Fine. Now you can apply again F1. F1 I can written as t plus C1 comma t square. Fine. Plus C2, this is the integration of F1 square is 0. So what is that? T into t square. Now you can integrate them. What is that? T into t square is a t cube. It's a 1 over 4. C1 t square. T square will be my integration is here. C2 f1 square. F1 square is a square plus b square plus this one. Fine. Now what is the integration of this? It is my 1 over 3. Integration of this will be my constant c1 square. Integration of this will be my 1 over 2. That's only c1. Now you can substitute the value. Is c1 is my minus 1 by, so it's 1 over 4 minus 1 over 6. This we need to find. It's 1 over 3. It's 1 over 4. It's 1 over 2. Now you can see what is that? It's a minus 1 over 6. It's c1 is minus 1 over 2. So what is that? It's a 12 is LCM 4 3 minus 2. This is my 7 over 12. This is my minus 1 over 2. So what is that? It's a 1 over 12, 8 over 12. 8 over 12 minus 1 over 2. So I can say 6 over 12. 2 over, so 1 over 6. So C2 will be my minus 1 over 6. Fine. So once you can see, is it correct? So we can see, I will recheck it calculation. You can see from here. What is that? T into t square is a t cube. Integration is 1 by 4. C1 into t square. So integration of C1 into t square is C1 over 3 plus C2 F1 square, that is t plus C1 square. So either if you open them, again you can integrate them. It's a 1 over 3. It's a C1 square. It's a 1 over 2, basically C1. Fine. Or otherwise you can integrate them. It's my here. So from 0 to 1. So I can write like here. It is 1 plus C1 cube over 3 and 0 will be C1 cube over 3. Previously I forget to write this bracket. So C1 is minus 1 by 2. It's minus 1 over 6 plus C2. C1 is minus half. It's 1 by 8, 1 by 24. Minus half, 1 by 8, 1 by 24. Fine. So it is my, what is that? It is my 12 is the LCM. 1 over 12. Again it is my 1 over 12. So C2 will be my minus 1. So C1, C2 here I can substitute this. It is minus 1. It's minus 1. It is my minus 1. So the right answer of problem is minus 3. So minus 3 is the right answer of this problem. Okay, now look at this another one. How you can move on this. Now you can see that this is not given to you as a vector. This is just like a series. So this is look like a functional analysis. Fine. But this is a question of the norm, so I can explain you here. Always remember, whenever there is a question on the L2 norm or the vectors or the space, then you can find the norm of the vector or norm of the function. You have to find the norm of the function. It's a functional norm. Fine. This is always with a supremum of modulus value over this domain X divided by norm of X. That's the simple formula for u. Now look at that. F is given to you as summation n is 1 to infinity xn divided by 2 raised to power n by 2. So I can start with the modulus of this. So what is that? This is norm is here. I can written this xn separate, 1 over 2 raised to power n by 2 separate. Do you remember any of the result which is product of this? Yes, by using the Cauchy-Schwarz inequality. What is that? This is less than of square root of norm of A, square root of norm of B. So I can written this number as less than or equal to square root of value of xn square. This is square of this. So this is xn square. Fine. Norm of this into square of this. What is the square of this? It is nothing but my 2 of n from 1 to. So what is that? This is nothing but my L2 norm. Fine. So once it's L2 norm, LP norm, so this is a norm of 2 space. What is that? This is a GP series. So what is the sum of the infinite sum of the GPs? A over 1 minus R. So this will be cancelled out. it is norm of x. Now you can substitute this value here. What will happen? This value will be, therefore norm of f will be, supremum of this is norm of x is less than or equal to norm of x. It will be less than or equal to 1. So this option will be cancelled out, this option will be cancelled out. Now you have to check whether it's half or not. Take any counter example, take any value of the x. Fine, it's 2 raised to power half. I can simply take root 2, 0, 0, 0. Fine, this is my x. Then can you find the norm of the x? It's because it's a single vector, so norm is also 2. What is my this value? And what is the mod of f? You can see if I substitute here, n is only 1. So this is my x1 over 2 raised to power half. So this is root 2 by root 2, that's a 1. So norm is my 1. So if I substitute in this definition, it will be 1 by root 2, that is root 2 over 2, which is greater than of 1 by 2. So it is equal to half, is a cancel out. So the right option is only left is the correct answer. Okay, look at this another one. It's a matrix is given to you, linear transformation operator norm. Fine. So I tell you in the earlier what is the definition of the operator norm. So you have, because this is the matrix A. So what is the definition of the norm of here? This is nothing but my trace of A transpose of A. Fine. You can simply find the A transpose of A. So that's, I think that's a very simple. You have a matrix. It's a symmetric matrix. No, it's a 1. Firstly, I can write the transpose 1, 1, 3, 2, 2, 2, 1, 3, minus 3. This into A vector. Fine. 2, 2, 2, 1, 3, minus 3. Then your target is to find the trace. It means you need only the diagonal values. So that's a first row, first column. So what is that? It's a 1 plus 4 plus 1. It's a 6. Second is the second row, second column. 1 plus 4 plus 9. So this is my 14. Third is third row, third column. 9 plus 4 plus 9. So 18 plus 2, 22. Fine. So what is the right answer of this? The trace is 6 plus 14 plus 22. So it's a 20, 40, 42 is the right answer of this. Fine. You can simply find the trace A transpose of A because it's a matrix value. Okay, look at this another one. This usual inner product space. So that's a standard one. Fine. That's a xi, yi. Un is given to you whether they are Li or not. What is the purpose of the Li? How you can check whether they are Li or not? So very simple. Li or so. You can simply take any of the two vector. Fine. Un and um. So 2 by pi is here. Sine n into t, sine of m into t. Now it's a standard inner product space over the domain this. It's a 0 to pi un into um. So if I take from the 0 to pi of un into um, what is the meaning of that? 2 over pi is common. This value, what will happen? This value will be pi by 2 if n is equal to m, otherwise it will be 0. Fine. So whenever n is equal to m, this integration will be my 1, otherwise 0. So what is the meaning of that? They are Li. Whenever this element on, so it is not a Li, cancel out. It's a Li, fine, but not a orthonormal. What is the property? What is the meaning of the orthonormal? You have to satisfy the two property. First one is norm of this should be 1 and inner product should be 0. So we can see the inner product is a 0 whenever n is not equal to m. And what will happen? I can return this number also as un of this. Fine. So whenever n is equal to m, its value will be 1 and root of 1 is a 1. So what is the meaning of that? This property is satisfied. but he said not, cancelled. It is an orthonormal subset, fine. It's not an orthonormal basis. Basis is not be there because you can see it is not always be a greater than 0. So this option is there. C is the correct option. Okay, look at this another one. Is the inner product defined to be here. X naught is given. X naught bar is the orthogonal complement. Which of the following is a complete? Okay, which of the following is a complete? What is the X naught? X naught is the element of all those X. Integration, if you compare them, what is that? It's the element, it's a what is the Y? Is that means this value is nothing but my t square. Fine. So I can return this as orthogonal complement of this, and we need a X complement. What is the X complement? We all know complement of complement is itself vector. Fine. And how you can prove the complete? Because what is the t square is? So this is the t square. So you can see this is my finite dimension. So what is the tips or remark always for you? That is, whenever you have a finite dimension space, fine, over this you can say the non-linear space or the inner product space is always a complete. Fine. We all know so the finite dimension space is a complete. So x naught is a vector of the t square which is over the domain clause 1. This is a finite dimension. X naught complement is again a t square which is a part of the 0, 1 is also the complete. So both are complete, rest options are cancelled. This is similar to the previous one. This is the same question. Instead of this here y, it is given to you as a y is t cube. Fine. So it means x naught is a part of t cube. Fine. Then no, sorry, x naught is a part of the t square. Sorry, x naught is a part of the t square if you compare them here. Fine. Then you have to find the best approximation. Again, it's the inner product, it's orthogonal. We can think about the projection rule. Fine. So what is my x naught? X naught is a part of this. So what is the projection value is? T cube t square over t square of this, and into what is the element of the x square is t. So basically here this is my projection. So what is the t square of t? If you multiply them, the complement is same. So what is that? It is my t raised to power 5 over this 0 to 1. Denominator is t raised to power 4 over the 0, 1. It is 1 over 6. It is 1 over 5. Answer is 5 over 6 into x naught. X naught is my t square. So 5 over 6 t square is my right answer. Look at the one more example. So which is given to you as a Supremum norm. Again, it's a function norm. So we can apply the same rule. Supremum of is my t of function divided by norm of f. Now norm is given to you as a infinity. Fine. So we can start with this norm mode of tf. What is that? It can be written like of this 0 to minus 1 f of dt plus 1 to 0 f of dt. So what is that? Now you can see norm of this supremum of this. What is the meaning of that? This value is always be less than of norm of infinity whenever t lies between here. So it lies between this. It is less than or equal to norm of this plus norm of this. So what is that? It is less than of 2 times norm of this. I can substitute here. So norm of t is less than or equal to 2. So the value of this upper value will be my 2 because we need a supremum of this. Upper value is my 2 is my correct answer of this problem. So this is the way you can solve the inner product question in very simple manner. We will see the next lecture on the testing of the hypothesis. We will see you can simply scan and join, and you can simply like and share my videos. Best of luck students. Happy learning.